All right, I'm here today. My name is Chris Cheen. I'm the SOC Director and CTO. I'm here today with Jay Ojo, who's Head of Content Management for the Security Operations Center. And we're going to be talking about the use of machine learning and AI in security analytics. So I think a good place to start is actually by debunking some of the myths around AI versus machine learning and the use of AI in security analytics. So, I mean, this is a bit of a conversation piece, but the standard definition around AI is really where, a computer is performing tasks that are routinely undertaken by an intelligent human being, essentially. So a computer replacing a human, which in security, Jay, it's a way off, really.
Yeah, definitely. We would definitely say that AI is definitely a way off from completely replacing the analyst. It still does need a lot of work. There is a lot of common misconceptions between the term AI actually being used when other terms such as machine learning should be used instead. So machine learning actually allows software applications to predict outcomes using historical data as their input and to predict new values or outputs, basically.
Yeah, so the takeaway here is some vendors will push marketing messaging around AI. Really what they mean is machine learning. So we're going to be talking a lot around how we can use machine learning here for security analytics and to make predictive assessments around when things are anomalous or suspicious or malicious. So I think one of the first use cases around using machine learning is for behavioral analytics. And I think one of the things that we often talk about is if you are hit with a real sophisticated attack, it could be a ransomware attack, it could have components of Trojans and worm-like malware capabilities. A lot of those are going to evade your traditional security tools. And Jay and I have recently been involved in a particular security incident where we've seen a complete email payload being delivered, which evaded the security email gateway. It was able to make command and control executions back to the attacker's domains, which were evading the proxies, and was actually arrived on a host that already had admin credentials that are cached on it. So the initial access mechanisms evaded all the security controls. There was no malware alerts, there was no proxy alerts to speak of. And what followed was obviously immediate privilege escalation because there was the cache credentials on the host, and a huge amount of other activity, which really was legit, could have been seen as legitimate because it was a legitimate user account that was doing it using inbuilt Windows processors. So the only effective detection mechanism is to look at the actual behavioral aspects of that. Jay, you want to talk about some of the things that we saw as part of that attack behaviorally?
Yeah, sure. So as Chris said already, we saw a lot of activity that wasn't picked up by the traditional kind of security solutions. And the reason behind that is most of the traditional security solutions are actually signature based. So what that relies on is that the vendor has to always update the signatures. And if the signature is not actually present within that security solution, then the actual threat won't be detected. So in this case, for example, there was a malicious email that had a malicious attachment. For the fact that that signature was not inside the solution from the vendor, it was allowed to bypass and get into the customer's environment. The same thing applies for the antivirus detection as well, because the antivirus detection was only based on signature and not heuristics, looking at specific behaviors. It was allowed to execute on the host. So using the actual usage of machine learning and other aspects of, let's say, AI, we can actually profile the behavior of certain executables and files that are running on the system and what actions they take. So what kind of files they access, what kind of connections they make, and we can actually profile the whole activity either of the machine or the user on a whole. So if we see, for example, we detect something where there's an executable that's never ever been seen before, and it's making calls to a URL that's never ever been seen before, or is accessing a large volume of files that the user, for example, in the context where the file has been executed, that has never ever been seen before, then us doing behavioral analytics will detect those kind of activities as and when it happens.
Yeah, I mean, so this can be simple Windows events.
Yeah.
We could be talking about profiling, excessive amount of explicit logons, excessive amount of things like PowerShell, WinRM, PSExec. And those are the sorts of activities that you're going to see in a complex ransomware attack, or where there's a worm-like malware activity that's going out and discovering all of the computers and trying to connect to those. It's going to be legitimate user accounts using those sorts of systems that you need to profile and baseline to look for the anomaly. Okay, so if we talk about practical application of machine learning, we use QRadar as a SIM tool, which has got a lot of features that we can actually deploy to actually do the machine learning, to do the user analytics and the anomaly detection. So within the rest of this discussion, what we're going to be talking around is the use of user behavior analytics and how that leverages machine learning models and how we can program those and how we can use some of the things that are already out of the box. And then we're going to be moving on to talk around the concept of business service profiling as well, where we're grouping services together, business services together into application groups and modeling, how they're communicating with each other and who's logging onto it, what processes are executing onto it. Okay, Jay, so let's start by talking around anomaly rules and how we can use those.
Yeah, sure. Thanks, Chris. So anomaly rules in a nutshell is basically where we search for anomalies over a certain time series of data. So we basically have 3 or 4 steps that we go through in order to create anomaly rules. And the first step is to identify and collate the data that we need to use in order to create the anomaly-based rule. So this would typically be, for example, logons associated with time data. For example, if we're capturing certain times, or we want to capture certain times at which certain users are logging on, or certain times where certain activities are being performed within the network. After that, we would actually go and take this data and collate it into a time series format. Using that time series format, we will now learn and use this to create a baseline of activity within the user or our customer's network. So for example, we will create or collect that time series data over a period of time from, let's say, 24 hours up until 7 days. From our perspective, it's better for us to learn for longer amounts of periods. So we would suggest any time from 24 hours to about 7 days. And that helps us to better reduce the possibility of false positives. So looking at the data on a broader timescale, we would now be able to compare any anomalies that happen outside of that timescale because we have a bigger amount of data.
Yeah.
Yeah.
I mean, so some practical examples of that could be if you're looking at firewall deny traffic, for example, and there's a baseline of consistent firewall deny traffic that you see in the network, and then you see a spike, they could suggest that there's something that's trying to call out or do some network enumeration discovery. Or perhaps we could look at a normal profile of authentication success even. We don't always need to look at failures. Yeah. And if we see a deviation with a particular user or a particular location that's got a spike in authentication success, and that's something we can look at. Or we can go more granular than that and start looking at specific processes that are executed on the system, particular objects that are accessed in terms of files and folders. Actually, it doesn't matter really. It's about looking at the particular what you're trying to achieve with that particular use case, and how you want to actually profile that as well.
Yeah.
So moving on from anomaly rules, now that we've actually got a system that we can take time series data on learned attributes, we can apply threshold activities or activity monitoring to that to establish thresholds at which, if we go beyond a certain limit, an alert's going to trigger. So that could be, excessive failed system crashes or excessive bandwidth, outbound transfers, and things like that. The problem with that, though, is obviously you've got to make a judgment call about what you consider to be bad. What's an excessive amount of bandwidth per user or per subnet or whatever the case may be. And there's always a problem that a user or an attacker may not hit that baseline. Not hit that threshold. So our opinion is thresholds are a little arbitrary. They're not really usable in terms of real behavior analytics. So we're saying don't use them.
Yeah, pretty much.
Yeah. All right, Jay. So that's the easy stuff done. Let's talk about more behavioural type of rules using pattern recognition. So within QRadar, there is a concept around behavioural rules, and these are where we're actually taking a season, could be a week, could be a month, could be a day, and then using that season as a continuous moving time frame to look at the rates and variation over time. So here, the most important thing is to actually define what that season is. And we've got to define that based around what the actual type of traffic is, whether it is human traffic, could be user logon type of activity, versus network type of traffic if we're looking at the communication between, I don't know, a database and a front-end web application. The season might be different. So if you take a user activity, for example, someone that goes away on holiday for 2 weeks, breaks that cycle, they come back 2 weeks later, and then obviously we're going to be generating a whole load of alerts because that seasonal difference will come into play there. So that's why we need to look at the type of traffic for the actual season. And then once we've got that, we can look at 3 specific things. The first one is the specific level, and that could mean, you know, the actual point in time difference between something that happened today versus something happened yesterday. Or we could look at, you know, user activity on a Saturday, every Saturday, and see how that profiles over time. So you're looking at a particular specific level. The next one is the actual trend, so that can be comparing data trends over time. So comparing minute to minute averaging or day-to-day averaging over a continuous learning period. And then the final one is to actually look at the traffic behavior on seasonal variation, seasonal differences. So if I've got a learning period of a week for a season and it's a moving season, I can compare season 1 to season 2 to season 3. So there's lots of different ways that we can use that data to look at specific levels, specific differences on variations on a minute-by-minute basis, or an hour-by-hour, or day-by-day, or then look at the overall seasonal differences over time. So this is getting a lot more complex now, Jay.
Yeah, definitely. So an example that we would give of this type of rule, what it would look out for would be a mail server, for example, that has an open relay and suddenly starts to communicate with many hosts. So as what Chris has already said previously, we may have looked at the data over a certain season and been able to ascertain that this mail server only talks to this amount of users, or these amount of users send this amount of emails via this mail server. The moment that we see that spike or a sudden volume increase in terms of that data, then that's the type of behavior that these type of rules would trigger. Another sort of rule that we would basically use for this type of machine learning algorithm would be alerts that come from IPS systems. So we would look at over a certain season the type of IPS alerts that are coming for certain IP addresses, be it endpoints or servers. We would look at the volume of it, and we would look at the nature of the exploit. If that changes over a season, then the rule will trigger. So let's say, for example, there's a web-facing server out on the DMZ of the customer's internet, and we're always seeing a certain stream or a certain type of attacks happening and being blocked on that IPS system. The customer, for whatever example or for whatever reason, they may have just deployed a new application, and then in that season, we may now see different types of exploit events that may lead us to a security incident where that application where the customer has just deployed, it may be vulnerable. So that would be the reason why we're now seeing the difference that's been highlighted to us due to the difference of the data that we're seeing coming from both seasons.
Okay, so we learned around the basic principles around how we can use machine learning algorithms to detect anomalies. But one of the practical applications of that is to use what we call user behavior analytics application to actually apply this in practice by ingesting logs to calculate user risk scoring. So Jay, why don't you take us through how this actually works in practice?
Yeah, sure. Thanks, Chris. So UBA, like Chris has already said, stands for User Behavior Analytics. We use IBM QRadar application within IBM QRadar to perform user behavior analytics. On a high level, how it basically works is 5 steps. So the first step is that log send data to QRadar. The second step is UBA's specific rules that we have looks for certain events depending on which UBA rules are enabled, and it triggers something called a sense event to be read by the UBA app. Those UBA apps specifically require a username and other kind of data to actually be within the events when the events are being detected, and those specific rules that trigger on UBA have something associated with it called a sense value. The sense value basically is a value that's assigned to it dependent on the severity of the issue or what the log says. So for example, if a user is seen to access a resource that he's not supposed to have access to, then the sense value associated with that event would be, let's say, 20. It could be set to anything arbitrarily that we want to set it, but the sense value ultimately determines what the risk is associated with that specific event. So after that, we basically take all the sense values and put them together, and we generate a risk score for a specific user. Once a specific user has a risk score that's over the threshold of the business, or what we can do is actually allow UBA to generate a dynamic risk score based on all of the events and all of the values in terms of sense scores that it's aggregating for all of the users that it's monitoring, then we can now trigger an offense to be generated when UBA detects that a certain user has a high risk score, and that's associated with the activity that they may be doing on their laptop, endpoint, or server.
So Jay, why don't you talk us through what we can see in front of us now?
Yeah, sure. Thanks, Chris. So on the far left-hand side, we can see that the monitored users tab. What this tab shows is basically, in a nutshell, is the 10 most risky users of a user's organization. So as we spoke about previously, this is the aggregated sense value score that's been aggregated for a user over a certain period of time. Typically it's 24 hours, and based on all of the activities that the user's done within that period, they're assigned a risk score. So as we can see in our video that we're showing you right now, our top most risky user is called Network Service. They have a risk score of 3.8K, and that's because they've been doing a lot of stuff that's been associated with risky things, which we'll get into later on in this video. On the next tab on the right hand side is recent offenses. So inside this recent offenses tab, this basically shows any offenses associated with the users that are currently being monitored through UBA. So that's basically just a snapshot and a glance of any kind of activities that have associated risk score with it, and it's just showing you basically the top users, or in the last, let's say the last period of when the actual app refreshes, so we'd say about 60 seconds, the offenses that the users have basically created or that's been generated or detected by QRadar. Further on the right hand side, we have the system score. So what the system score is the overall risk score of the whole business on a whole, and QRadar basically keeps a track of that and plots that over the period. So as we can see, during would say around 11 o'clock, the risk score of the overall business has gone up to about 30K. This is dependent and probably aligned with a lot of things like what people that work for the organization is doing, and we can see a steady decline as the day comes to an end, and we can see by about 4 to 5%, but 4 to 5 p.m. that the risk score has gone to a very minimal or bottom or gradual or very low levels, because everybody has finished work and there's no kind of risky behavior happening. Slightly under that is the risk category breakdown, which basically shows what risks have been identified and what the nature of the risk is. So we have things such as user geography change, we have user privilege, we have user access, we have resource risk, and we have detections associated with our machine learning. On the far left-hand side, under monitored users, we have the active investigations. What this is basically that users that are under investigation for the nature of the activity that they've been conducting because of their risk score. So as we can see, Network Service, as we mentioned previously, they have a high risk score of 3.8K. So we've kicked off an active investigation just to investigate what kind of activity that they've been doing and to further drill down to understand the context behind it and what that user's been doing and whether it's risky or not. Just to the right hand side of that is the users with dormant accounts. That's pretty much self-explanatory. So UBA is able to identify users that have dormant accounts by actually not seeing any kind of activity on the network, whether it's people logging on or people using their accounts to access resources or things like that. So UBA is able to track the dormant account activity inside a user's organization. If anything happens with the dormant accounts or they become live or something of that nature, then any kind of risky activity that's associated with a dormant account, automatically it will be moved into the monitored users and be monitored as per a standard account.
So Jay, beyond use of UBA, there is other more custom rules that we can use outside of that framework to be able to look for specific risk hunting type of activities. And I think one of the examples that we'd like to use is just finding abnormal use of normal Windows systems services like PowerShell or WinRM or PS6F, or those sorts of privileged tools can be machine learned. And we can do that in a number of ways. And the first thing to say is that, you know, ideally we'd have something like an EDR or sys1 events coming into the system. But even if you don't have those, you're likely to have a new process creation events on servers, which is your Windows Event ID 4688, which is going to tell you when a new process is actually created. So what we can do is we can take the actual process name and we can use that to identify the combination between the user and the process name, what command they're actually executing. And then once we've got that data, we can learn it in a couple of different ways to identify where there are abnormalities in, let's say, PowerShell type of activities by learning PowerShell as a process name and machine learning that. So we've got two examples which are just showing two different types of techniques. And the first one's quite simple. It's using the concept of a reference map. And a reference map is just where we're basically taking a note of an activity at a point in time. So it has the concept of a key and a value. In this case, the key that we use is the username, and the value, which could be multiple per username, could be the command that's being executed as part of a PowerShell script. So let's start with the reference map approach and look at where we're seeing unique PowerShell commands, never been seen before for a particular user, using that learned behavior model.
Our first rule is called Find Unique PowerShell Commands for Users. And basically how that works is that we look at event 4688 on Windows. What we take into consideration is the process name and the process command line. We basically take all of that information, we constantly gather that information into a reference set, and this is every single unique kind of execution that's happening associated with that specific user. So over a period of time, what we're able to do is once we see a new command that we've never ever seen before that's been executed, we will be able to detect it straight away. So for example, as the screen shows now, there's a process commonly that runs where there's a service and the service is always run and executed by PowerShell. If a situation happens where a new process is detected with a different kind of command, for example, the second one, which is PowerShell.exe, with a web client downloading from an external domain and executing some sort of code, we'll be able to detect that instantaneously because we already have the baseline that we've gathered out of all of the PowerShell's commands that are being executed generally in the context of that user. So we'll be able to identify outliers immediately.
So we're saying it's not explicitly bad until an analyst is pointed to look at this particular command they otherwise might have not identified. It's just a way of flagging the anomalous nature of that command. It's never been seen before for that particular user.
That's true.
So that's the most basic type of machine learning, where you're just writing stuff down to a database to reference later on. Okay, so we've shown you how we're going to create a basic machine learning algorithm using reference sets for PowerShell user activity over time. But there is another way that we can do that using QRadar, and this time using the machine learning app of QRadar itself, which is going to allow us to build in much more of a complex machine learning algorithm that's using normal distribution type of analysis to understand the degree of abnormality with a particular user activity based on the criteria that we set. So using the same principle here, I want to understand maybe one or two things. I want to understand the uniqueness of the PowerShell command that is being run by that particular user over time. So if I'm a normal administrator and I start running multiple unique PowerShell commands from a particular system, that would be considered to be abnormal for that user. I want to be able to generate an alert based on that. Or potentially I might just want to have a look at the volume of PowerShell commands for a particular user over time. You might have someone as a normal user who never uses PowerShell as part of their normal business operations and all of a sudden starts to. Well, we have to machine learn that sort of baseline, and the machine learning app within QRadar helps us to be able to do that. So what you can see in front of you on the screen is some of the machine learning models that are already baked into the system. And you can see down the left-hand side here a number of those different types of models. So the access activity monitoring, the authentication activity monitoring, and so on. That's interesting. But on the right-hand side here, if I click on creating a new model, what I can actually see here is I can start to understand the various different built-in models that I've got here. So I can look at Office 365 activity in terms of the file create, read, write, and updates per user and machine learn that over time, or similarly the S3 activity. But in this case, what I want to do is look at the process creation uniqueness of a particular user and machine learn that. So I'm selecting here the process command line and selecting a unique count. So using a certain criteria, for example, I want to exclude normal machine accounts, dollar accounts. Take that out, filter that out, and I want to select only process ID 4688 which is a new process creation event on a normal Windows system or a server. And I want to exclude those process command lines that are blank, because I'm going to have a few of those. Okay, we're not interested in those. Finally, I want to see only where I see process name as PowerShell. So building that criterion here allows me to build that model based on all of those different parameters. Just going to give it a name here. I'm going to call it PowerShell, user activity by unique count, or something similar like that. Something that the analyst will completely understand just based on the raw name, what it is we're trying to achieve here. And pasting in the description here, from the bottom here, you can see this model is a unique count of the field process command line for a particular user. Paste that into the description so that the analyst, when he comes to understand this, will understand what we're trying to do. You can see also on the left-hand side that we've got a number of different fields that we can start to select to identify how we're going to program this. So I'm going to set a risk score of 100 for this, and I can set anything. And then I'm going to allow that sense risk score to scale with time based on the number of standard deviations and away from the normal distribution. So just selecting that allows that risk to scale. So if I'm 2-3 standard deviations away from the norm, I'll be able to see that. And finally, the data retention period on the rule itself. Here I've got it set on 30 days. So that's as simple as that. So it's a question of us understanding what it is you're trying to achieve from a machine learning rule, configuring it so it makes sense in terms of the data it's trying to collect and the length of time you're trying to program that over. So now we've got this rule in place, we should be able to run it. So we're coming towards the end of the session now. And just to recap on basically what we've gone through here, we've attempted to identify a few different basic methodologies for how we can look at behavior analytics using machine learning to be able to identify outliers in behavior, which allows the SOC analyst to then go and identify those outliers, investigate and put it through an incident response process to a triage, what it is that has actually gone wrong and what we need to do about that. I hope what we're trying to show you here is that yes, you have to have an idea as to what you're trying to profile, but it doesn't need to be that complex. There's a lot of myths that need to be debunked around machine learning and AI, and we're only scratching the surface with this 25-minute session here to be able to show you what can be done. We could go on to talk about network analytics or using things like IBM Watson to do link analysis out in the cloud. It's a big subject. There's lots that we can discuss. It gets quite mathematical. This is just an introduction into that. But the point is, these methodologies need to be used to identify those things that are abnormal. If you don't do that, then you're only relying on your security tools to be able to tell you explicitly what is bad and what is good. So it is an essential part of your detection strategy. So thanks for joining us, and we hope this has been informative for you. Thank you.